I'm going to do an example on going between a displacement time graph to a velocity time graph to an acceleration time graph. Let's begin with this displacement time graph. So displacement, if you recall, is a lowercase s, arrow on top because it's a vector. It's got a direction versus time. Okay, that's the title. Let's sketch time of the x-axis. Let's say seconds, and displacement on the y-axis, let's say in meters. And it looks something like this. I'll put in some numbers. I'll do the best I can with it. It's not to scale, but anyway. Oops. I'm not good at drawing graphs, let me tell you. Okay, we'll go up to, let's say, 30. Okay, something like this. So it's a curve here, then it lines up in a straight line, and then it curves back up again, and it goes flat. Okay, I'm given this, and I need to go from this to a velocity time graph. So let's do it. So with these graphs, so v for velocity, there's a vector. With these graphs, time, the x-axis always stays the same. Right, time doesn't change, it stays the same. So it's going up by twos. Let's go up by 2 here similarly, 2, 4, 6, 8, 10, 12. And we need to work out the y-axis. Now, what do we do? Here's what we do. We need to first break up this graph into segments. Now, what we see here is, so from 0 to 4 seconds, I haven't drawn it right, but anyway, this should be like a curve. Between here and here, there's like a curve going up. Let's call this area 1, region 1. From 4 to 8 seconds, it should be a straight line. So this is region 2. And from 8 to 12 seconds, this is a curve that's flattening. So 8 to 12, this is region 3. So to go from displacement time to velocity time, we need to use the formula velocity is displacement divided by time. So this gives you a hint, this formula, as to what you need to do to get velocity. Now, you need to work out the gradient, the slope of these regions. From 0 to 4 seconds, it's accelerating. The object is accelerating because it's a curve going upwards. So if there's acceleration, there has to be constant velocity. So from 0 to 4 seconds, the graph should look like this. Now, where does it stop? Let's work this out now. From 4 to 8 seconds, the velocity is changing. Between 4 and 8 seconds, the velocity is constant because it's a straight line on the displacement time graph. Because my graph's so messy, suppose you did rise over run here. Okay, the rise and the run. You find the slope, and you should get, let's say 4. Put 4 here. You get a flat line between 4 and 8 seconds. So you have a straight line going up because there's acceleration between 0 and 4 seconds. Between 4 and 8 seconds, there's constant velocity. And from 8 to 12 seconds, you're getting a curve that's going back down again. And that's deceleration. If it's deceleration, it means the velocity is going back down again, like this. So that's our velocity time graph. Let's now go to an acceleration time graph. Let me first break this up. 1, 2, 3. Okay, time as always stays the same. Acceleration is a vector, meters per second squared. Zero, 2, 4, 6, 8, 10, 12. So how do we work out acceleration? Acceleration by definition is the change in velocity, v, over the change in time, t. So according to this graph here, we need the gradient once again. So the gradient of region 1, rise of a run, so the rise is 4 and the run is 4. 4 divided by 4 is 1, according to this formula. So the acceleration is 1. Between 0 and 4 seconds, it is 1 meter per second. Now, I'm leaving out the other numbers on the y-axis just to keep things simple for now, but I'm sure you know how to go up by a suitable scale. So 1 meter per second, it's a flat line. If something's accelerating, something's moving at a velocity like this, increasing velocity over time, it's accelerating, constant acceleration like this. So that's region 1. Region 2, constant velocity means there's 0 acceleration, so it drops down to 0. Okay, if you're moving at constant speed, you're not accelerating. So from 4 to 8 seconds, drops all the way down to 0. So let's drop this line all the way straight down to 0 here, 0 acceleration. So from 4 to 8, it's a flat line. I should also extend it to the negative axis here. This is region 2. Region 3 is there's deceleration, and the gradient is the same, but with a minus sign. This is a positive gradient, positive slope. This is a negative gradient. And if you do rise of a run, you should get -1. So this drops from 8 to 12 seconds here. This drops down to -1. So straight down a vertical line all the way to -1, and it goes flat again. -1 meters per second. So that's a simple example there of how to go between the 3 different graphs.